So in this video, I'm going to talk about solving nonlinear equations graphically. And the first thing I wanted to go through is what are linear or nonlinear equations. So linear equations are straight line graphs, but nonlinear equations are not straight line graphs. The first example are the quadratic graphs. You have the U shape and then this upside down U or N shape. And quadratic graphs, the highest power of x is a 2. So x squared is the highest power of x that you get. And of course, if the x squared has a negative number, this here is a -1, then the graph is not a U shape, it's an N shape. Then you have cubic graphs. This is an example of y equals x cubed. And this one is an example of a graph where the x cubed has a negative coefficient. So this could be a negative x cubed. But this graph could be the graph that has other values for x. So plus 2x, maybe 2x squared, minus 5x, minus 4, something like that. So it could be as simple as this, or it could be a much longer equation, but in any case, the highest power that you see on an x is 3. It's a cubed. And then you can have reciprocal graphs. And reciprocal graphs, this one is the equation of y equals 1 over x. So reciprocal graphs are fractions, and the variable, the letter, the x, is at the bottom in the denominator. The other graph is similar, except it is y equals -1 over x. So these are mainly the three that you are asked to plot, and also the 3 types of equations that they could give you to solve. Before we do that, I want just to talk to you about the principle behind this topic. So if I ask you, do you agree with this statement? If 8 equals 6 plus 2 and 8 equals 11 minus 3, do you then agree that 11 minus 3 equals 6 plus 2? Of course they equal each other because they both equal 8. Well, in the same principle, would you agree with that? Y equals x squared plus 2x minus 5. Y equals 3. That means that x squared plus 2x minus 5 also equals 3. Yes, it does, because this equals y and this equals y. Therefore, they equal to each other. Now, this is an example of a quadratic graph, a graph that looks like this. Y equals 3 is a horizontal line, and it will cut the equation or cut the quadratic graph in 2 places, and we are trying to find the values of x. So if I put axes, so let's put an x-axis and a y-axis, I am trying to find the values of x that make this equation equal. So if I substitute a value for x, I want to get a y value of 3. So this is the line y equals 3. It cuts the y-axis at 3. And I want to find the x values where the quadratic and the straight line meet. So the first example here says this is the graph of y equals x squared minus 2x minus 3. Solve the equation x squared minus 2x minus 3 equals to 0. This is the first graph, which is a quadratic, and it's already plotted for you, and the 0 is the second graph. Effectively, you have y equals x squared minus 2x minus 3, and y equals 0. That's why I can write them next to each other, because they both equal to y. This one is already plotted for you. So the first thing you need to do is plot y equals 0. That's your step 1. Well, y equals 0 is a horizontal line. All these lines that don't have an x on the other side, they just have a number, y equals, are horizontal lines that cut the y-axis at the given number. This is y equals 1, y equals 2, this is y equals 0. It's actually where the quadratic graph cuts the x-axis. And these are nice values here. The quadratic graph cuts the x-axis, the line y equals 0, at -1 and at x equals 3. So the second step is to actually give the answer. The solution to this equation is x equals -1 and x equals 3. You could actually just write it as x equals -1, 3. So these are the values for x. If you substitute these values in, you will actually end up with an equals 0. So I will show you what I mean. X squared when x is -1, so -1 squared minus 2 times -1 minus 3. Well, -1 squared is 1. 2 times -1 is -2, but there's another negative there, so that makes it a +2. Then I've got a -3. Well, 1 plus 2 is 3, take away 3 equals 0. So these values for x make this equation correct. The second example, very similar. This is the graph of y equals x squared minus 2x minus 3. Solve the equation x squared minus 2x minus 3 equals to 4. Again, I've got effectively two equations. Y equals x squared minus 2x minus 3. And that one is already plotted for you. It's that quadratic. And the second equation is y equals to 4. And that one isn't plotted. So your step 1 is to plot the line y equals 4, which is a horizontal line that cuts the y-axis at +4. So this is the line y equals 4. And you can see that it cuts the graph here and there. And you want to be very accurate. You want to get your ruler and you want to place it where the two lines meet. Well, the line and the graph, and then trace it down to the x-axis. And same here, let me try and get that right there. So this is 3, and this looks like a 4.8, 3.8, so x equals 3.8. And this one is, this is -1 over there. So this again looks like -1.8. And these are the solutions. These are the answers to the equation that we're trying to solve. The next example is a little bit different, because on the other side you have an x plus 1, an x and a number. So it's not just going to be a horizontal line, it's going to be a diagonal line. So here are the two equations, y equals x squared minus 2x minus 3. And that one is already plotted. It's the quadratic, because the question says this is the graph of y equals x squared minus 2x minus 3. And the other equation is y equals x plus 1. And you know it's not just a horizontal line because there is an x term. Now, you could do two things. You could create your table, because you need to plot this line. Table with x and y. And the values that you pick for x are the values on the x-axis. So I'm going to start with -3. All you need are 3 values. And I always like to choose x equals 0. And then I'm going to pick the last value on the x-axis, which is 4. And to get y, you are told that it is x plus 1. I like to start with the positive numbers, so I'm starting here. When x is 4, x plus 1 makes 5, so y is 5. When x is 0, x plus 1 makes 1, so y is 1. And when x is -3 plus 1 is -2. And you've got your coordinates, -3, -2, 4, 5, and 0, 1 that you can plot. So I'm going to start plotting. -3, -2 is there, 0, 1 is here, and 4, 5 is there. And you get your ruler, and it's a straight line graph, so you have to join it with a ruler. And you can see that the line cuts the quadratic graph in 2 places. It cuts it there at x is -1, and also if I use my ruler and trace this down, you can see that it cuts it at x equals 4. So if that is step 1, step 2 is to give the answer, the solutions, and it's x equals -1 and x equals 4. Now, you could have done this, or you could have used your calculator to find your coordinate table. So I've got my calculator here. You need to go to menu setup, and you need to use your arrows until you find the table mode, which is 3. So I'm going to either click equal to choose 3 or type 3. F brackets x, f of x just means y equals. So you need to type in the equation of the line, which happens to be x plus 1. To get the x, it's above the bracket button, and it's in pink, so you have to click on the alpha button at the top of the calculator. So alpha brackets gives me an x, and then I type +1, and I click equal to choose. Now if it gives you another letter with an x, it wants you to put another equation, but we only have one equation, so I'm going to ignore that just by pressing equals. And it tells you where do you want to start your table range. So it's asking you for the values of x. Well, I'm starting from -3, and I want to end at 4. So use your arrows to go down, or the equal sign, in fact. So press equals to go down, and I want to end at 4. And I'm going in steps of 1, because you can see from -3, -2, -1, 0, 1, 2, 3, 4, it's increasing in increments of 1. So I press equal again and press equal, and it gives you the value for x and the value for y. So f of x stands for y. And you can see it's exactly the same as my table -3, -2, and I went for 0 and it was 1. And if you use the arrows to go down, it will give you the rest of the values 4, 5. So you can use the calculator also to find your coordinate table. Now, this example is a bit different because it asks for something different. It doesn't actually ask for you to solve an equation. It tells you the equation of the graph. This is the graph of y equals x cubed minus 13x plus 12. And it says find the highest value of k when y equals k gives 3 solutions. 3 solutions means you're looking for 3 places that this line cuts the graph. So this y equals k, k is a number, so this is a straight line. In fact, it's a horizontal line, because k is a number and y equals 1 or y equals 0 or y equals -5, whatever it is, all of these are simply horizontal lines. So the solution when this graph has 3 answers is where this graph cuts the line 3 times, or the line cuts the graph in 3 places. So let's have a look. Here, let's start there at the very bottom. If I draw a line there, you can see from my ruler that it only cuts the graph once here. That's not what I want. If I go there, it does cut 3 times, but it's not the highest value of k, so around here is about y equals -6, and it cuts there, so it cuts here, here, if I move it there and there. So that's the lowest value of k, which is -6. But the question says they want the highest value of k. So if you keep going up, it cuts it 3 times. Cuts 3 times, cuts the graph in 3 different places, cuts the graph in 3 different places, but it's not the highest value. So you keep going up until you get to the turning point. So you keep going up until you get to the turning point. And at the turning point, y equals to 30. And that's the highest point where the graph cuts in 3 different places. It cuts here, cuts there, and it cuts there. So the turning point, there are 2 places where it cuts. Therefore, that's what the 3 dots mean. K equals to 30. That's the highest place. That's the highest value of k that gives 3 solutions. Sometimes they might ask you for an inequality, because they might ask you for the highest and the lowest value for k. If they do that, k is going to be bigger than -6, but it is smaller than 30, because that's the lowest and that's the highest value of k that gives 3 solutions. So that's what a question like that is asking you to do. Now I want to show you that sometimes you can change the equation or change how it looks, but it actually will give exactly the same solutions. You haven't actually changed the value of the equation. So here I've got 2 graphs that are equal. You've got y equals x squared minus 5x plus 12, and you've got y equals 2x minus 3, and I've made them equal because they both equal to y. But I can play around with this and I can change the way it looks. For example, if I take away 2x from this side because it's an equation and it's equal, I have to take away 2x from the other side. I have to collect like terms. So I now have an equation that looks like this: x squared minus 7x plus 12 equals -3. These two equations are exactly the same. They are identical. They might look different, but they're exactly the same equation. I might decide that I don't want it to equal -3, I want it to equal 0. So I could add 3 to this side, that will make this side 0, but because it's an equation I have to do it on the other side. And now I have an equation that looks like this: x squared minus 7x plus 15 equals 0. The first equation, the second equation, the third equation are exactly the same. They will give you identical solutions. I rearranged them, but I haven't actually changed anything fundamental, so they will give you the same solutions. Now let's have a look at an exam question and how this can be applied to it. So a typical exam question will start by asking you to plot, to complete the table of values and then to plot the non-linear graph. So for that, again, I'm going to use the calculator and I'm going to input the equation of the graph, which is y equals x squared minus 2x. I'm going to input the x squared minus 2x. So again, alpha bracket, so that's my x squared minus 2 and then alpha bracket to get the other x. And I'll press equal and I'll press equal again and it will tell me the start. So the start is the start value of x, which is -2, and the end is going to be 4. So -2 equal, and 4 I've got, and I'm again going up in increments of 1, so I'm going to put equal. And this will give you the table of value. When x is -2, y is 8. -1 and 0 are given to you, and it's good to check. So -1 gives us 3, 0 gives us 0, and then 1 gives us -1. And you use your arrows to go down. So 2 gives us 0, and 4 gives us 8. So 2 gives us 0, 4 gives us 8, and 3 did give us 3. Wonderful. That's usually a 2-mark question. And then we plot. So I'm going to plot -2, 8. So -2, 8 is there. And then -1, 3. So 3 is in the middle between 2 and 4. There. 0, 0 is here. 1, -1. So again, -1 is in the middle between 0 and -2. 2, 0. 3, 3. Again, 3 is in the middle between 2 and 4. And then 4, 8. And then you have to connect to create the quadratic. So this is a quadratic graph because the highest power is a 2. And it's looking like a U shape. And you have to connect it without a ruler. So it should be a smooth curve and it has to have a dip at the bottom, which this will naturally dip at the bottom. But if it didn't, you need to make sure that there is that dip. So a smooth curve and there we are. And then we come and look at the final question, which says solve x squared minus 2x minus 2 equals 1. Now have a good look at the graph that you've plotted, and have a good look on the left-hand side of the equation. They're not the same. So what you need to do is you need to ensure that the left-hand side is exactly the same as the left-hand side of the graph that is plotted. So they both have x squared, so we don't need to do anything. They both have a negative 2x. But the one plotted doesn't have a negative 2, so I need to get rid of this negative 2. I can get rid of it, I can make it to 0, because that's what there is here, it's a plus 0, by adding 2. But of course, whatever I do to this side, I have to do to the other side, because it's an equation. It's like a balance. You have to keep the balance. So whatever you do on one side, left-hand side, you have to do to the right-hand side. Minus 2 plus 2 is 0, which is what I want. And then 1 plus 2 is 3. So that is effectively your step 1. You need to make sure that the left-hand side of the equation in the question, that's the question, is exactly identical to the equation of the graph plotted. Now that you've done that, you have your two equations. You have y equals x squared minus 2x, which is already plotted. You plotted it. And the other equation, which is y equals 3. And because there are no x's on the other side, this is simply a horizontal line at y equals 3. So y equals 3, and it gives you nice solutions, because at y equals 3, x equals minus 1 and x equals 3. So you're going to, so that's, if I call that step 1, and finding the equation of the line is step 2, plotting the line is step 3, and then step 4 is actually giving the solutions. So it's x equals minus 1 and x equals 3. And that is solving non-linear equations graphically.